Let us next solve exercise 14. In this one, we have to prove that any matrix A and its transpose are similar. The solution starts by considering matrices like this, J. We have already seen this type of matrices when we discussed Jordan canonical form. On the main diagonal, we have all these lambdas. The super diagonal consists of 1s and elsewhere it's 0. So if you take the transpose of J, that super diagonal will turn into sub diagonal, the lambdas won't get affected, and elsewhere it's 0. Alright. Now let us consider this matrix C. You can see that the matrix C is like this. So it's not the main diagonal of C that has these 1s, but that other diagonal, and elsewhere we have 0. Now if you take the conjugate of J by this C, Cj C inverse, one fact about this C is that C is invertible, and actually the inverse of C is itself. This is a very easy thing to verify. So Cj C inverse is equal to Cj C. Now if you do this calculation, you will see that you are getting J prime, that is J transpose. So from this we get to know that at least J is similar to its transpose, and now we are going to use this information to say how A and A prime are similar. Let's see how. So next what we do, we consider the minimal polynomial of A and its splitting field K. Let K be the splitting field for the minimal polynomial of the matrix A. Then by theorem 662, which of course is in the section on Jordan canonical form, there exists a matrix B in Kn, in the algebra Kn. That means the entries of B are coming from this extension K, such that BA B inverse has this block diagonal form, where the blocks are Jordan blocks. Okay. So next what we do, we consider this conjugate of the transpose of A by B transpose inverse. You remember in the previous linear algebra video, we proved that for a non-singular matrix, for an invertible matrix, inverse of transpose is equal to transpose of inverse. That thing we can now use. So B transpose inverse will be equal to B inverse transpose. And then of course in place of this product we can write the transpose of this entire product. The only condition is that the order will get changed. Here we have B inverse A B, here we will have B A B inverse. So the transpose of that. That means the transpose of this, because this is the block diagonal matrix, we have to take the transpose of each of the blocks. So what do we see from here? From here we see that the matrix A transpose is similar to this block diagonal matrix. Now let us recall that each such Jordan block J is similar to its own transpose. That's how we started the solution. So then what is the consequence? So we write that thing, since each Ji transpose is similar to Ji, this matrix, the last matrix means this matrix is similar to this matrix. Because this is block diagonal, this is also block diagonal, and each Ji prime is similar to Ji. So you can use those similarity relations to construct a matrix of this size. That will give you the similarity between this matrix and this matrix. So these two matrices are similar. But A prime is similar to this, and that is why A prime is similar to this matrix. However, this matrix is nothing but BA, well, it's not B transpose but BA B inverse. Let me change this. Okay, so A prime is similar to BA B inverse. That will imply that A prime is similar to A. However, the solution actually doesn't end there. So let me write the things and then we will see why it is not the end. So we write that conclusion here that A prime is similar to A, but the problem is that it is similar to A in Kn. So that matrix by which you will have this similarity between A prime and A is a matrix in the algebra Kn, not exactly in Fn. It may be in Fn, but we don't know. Okay. However, if you go to the section 6.7, which discusses rational canonical form, there we will see that the last result, that is corollary to theorem 673, ensures that in this case A prime is actually similar to A in Fn also. So that is how finally we have this claim proved. Okay, so that's the solution. And let's just end this video here itself. I find making longer videos more and more pointless because no one is really watching. But anyway, I will keep making videos, but they will be short like this. So tomorrow we have analysis again. So see you tomorrow with that. Until then, this is me, Lucifer from a mathematical group. Have a nice day.